Hi everyone. Today we're going to talk about section 10-5, which is our tangents of a circle. A tangent is a line segment or ray that intersects a circle in exactly one point. So for example, here we have two tangents, RS and ST are both tangents to circle P. We also have a point of tangency, which is this point P. It's the point where a tangent line hits the circle. Oh, sorry, not P. R and T. So R and T would both be points of tangency because this line comes and hits the circle at point R, hits the circle at point T. P is our middle of our circle. It's how we name our circle. Theorem 10-10 tells us that a line is tangent to a circle if and only if it is perpendicular to a radius. So we're always going to have a right angle forming here with the radius and the tangent line. QP is a tangent to the circle at point P. OP is a radius, like I just said. So these are perpendicular lines. Now, if we apply this to a problem here, I have AB as my tangent to circle C at point B. The hardest part of this problem here is we know this is a right angle, so we are going to use Pythagorean theorem to find our missing side x. The hardest part, though, is that this whole side is not 9. So this piece A to D is 9. We don't know this piece D to C. You have to be able to recognize that this is a radius. This is a radius 8. This is also 8. You have to be able to recognize that these are both radiuses. So DC and BC are radii. You have to be able to recognize that. Okay. Now let's go ahead and set up our Pythagorean theorem now that we know this whole side is 9 plus 8, which is 17. So across from the right angle is your hypotenuse, so that's our 17. So that should be on that side of the equal sign. Then we have x squared plus 8 squared are my two legs. Okay, so now I have this equation. I know that 8 squared is 64 and 17 squared is 289. Then I'm going to subtract this 64. I get x squared equals 225. If I take the square root of both sides, I get that x is 15. Okay, so I've now found that x is 15. I'm all set with that problem. Now, if I go to 10-11, that theorem tells me that if two segments from the same exterior point, so the exterior point is A, these segments are both tangent to the circle, then they must be congruent. So AB and AC are both tangent to the circle, so that means they have to be congruent because they have the same exterior point. So now going back to down here to this picture, this is supposed to be a Q. It says that NP and QP are both tangent to the circle. So that means they're both using the exterior point P. They must both be congruent. So X would just equal 12 here. They should be congruent. Okay. Now moving on to the next page, the back side here, we have circumscribed polygons. A circumscribed polygon is a polygon with its vertices outside the circle and its sides tangent to the circle. Now, just like we just said, if these sides are both tangent, they have the same exterior point, these are congruent. 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 Okay. All of those outside lines are tangent, and they all share an exterior point. So whatever line shares the exterior point with the other, those have to be congruent. So if I'm looking at this picture, ABC is circumscribed. That means it's inside. Okay, it's outside of the circle of circle O. Find the perimeter of ABC. Okay, so we have triangle ABC. It's circumscribed, meaning we have a circle inside it. Find the perimeter. Well, these two lines, BD and BE, are tangent to the circle. They share the exterior point B, so they should be congruent. A is the exterior point shared by AD and AF, which are both tangent lines, so they should be congruent. So this should be 12. This should be 6. Likewise, these should be congruent, so this should be 8 because FC and CE are tangent lines sharing that exterior point C. So now I've labeled every part of my triangle. I can now find the perimeter. 6 and 6 is 12. 8 and 8 is 16. I'm going to add those to get 28. And then I have 12 and 12 is 24. 8 and 4 is 12. Carry the 1. I get 52 for my perimeter. Okay. If you have any questions with this, please reach out to my office hours today. They are 11 to 12. Okay. Have a great day, guys.